Alright guys, so what we're going to be looking at here is we're going to be looking at what's called the product rule. So up until this point, alright, anything that we had a product, it was split up with pluses and minuses. But now we're going to look at what happens if we are multiplying two separate or individual functions in themselves together. Alright, so the product rule or notes tell us on derivatives page 21 that the derivative of the product of two functions is the first function times the derivative of the second plus the second function times the derivative of the first. And so what they have is they have the derivative of f of x times g of x is actually equal to, we have f of x times g prime of x plus, and then we have just g of x, the original, times the derivative of the first. Okay, so an easier way, because that kind of looks a little crazy, a lot of stuff going on there. All right, if I have something 1 times a whole nother something 2, what I can do is I'm going to just take 1 times 2 prime plus, I'm going to take whatever 2 was originally times 1 prime. All right, so that's kind of my setup that I'm thinking of when I'm doing these problems. So here's my little thought bubble. All right, that's what I'm thinking of when I'm doing these product rule problems. So let's look at the very first one. You have, we want to find y prime if y is equal to 2x squared minus 4x times 3x minus 5. Okay, so without the product rule, what we would have to do is what we were doing yesterday, where we would actually have to FOIL this out. Okay, so that would be 6x to the third, all right, minus 10x squared, minus 12x squared, plus 20. Okay, and this is without the product rule. So what would that give us? That would give us 6x to the third minus 22x plus 20. All right, and that is y. So we have to take y prime of this, which is 3 times 6 is 18x squared. All right, 2 times negative 22 is negative 44x. All right, and sorry, that was a 20x on the end. So this is just plus 20. Okay, so let's look at the new stuff for today. What would happen when I do this with the product rule? So this is with our new rule, the product rule. Okay, so what I'm going to do is I'm going to rewrite my function 2x squared minus 4x. And I'm going to look at 3x minus 5. Okay, so kind of what we have here is we have two pieces. So my first piece, all right, my 1, so to speak, is that. And my 2, all right, which I'm going to do in this light green color, all right, is 3x minus 5. So I'm going to use my rule that I have. All right, I have 1 times 2 prime plus 2 times 1 prime. Okay, we're gonna look at that. All right, so what is 1? Okay, so y prime is actually 1 times 2 prime. So we have 2, let's change colors here. All right, plus, then you have 2 times 1 prime. Okay, so 2 times 1 prime. All right, so let's look at what those are. Okay, so I'm just going to go back to one color here. All right, the very first thing, it is 2x squared minus 4x, excuse me. All right, times the derivative of the second. The derivative of the second is just 3. Plus, then we're going to take just the second, 3x minus 5. We're going to multiply that by the derivative of the first. And the derivative of the first, 2 times 2, is 4. all right, minus 4x, minus 4. Okay, so product rule gives us something a little bit different. That's 6x squared, minus 12x. Okay, and then plus we have to actually FOIL this out. This is 12x squared minus 12x minus 20x plus 20. Okay, and then let's look and see what happens here. When we simplify, we do all this algebra. All right, 6x squared plus 12x squared is an 18x squared. Negative 12, and negative 20 gives me negative 44x and plus 20. So in both cases, all right, whether using the product rule or not using the product rule, we still get the same exact answer. Okay, let's look on to something like C. So I'm going to move on. I'm going to let you guys do B on your own, all right, and I'm going to do C with you. So here we have f of x equals this long thing of stuff. So 3x squared minus 2x plus 5 times negative 5x to the 4th plus 2x to the 3rd minus 7x squared plus x plus 2. Okay, so here we go. All of this right here is my 1. All right, we're going to use the product rule for this one. And all of this here is my 2. Okay, because I really don't want to have to FOIL that out and go each by each. It's going to be a really, really long thing to do. So let's use our rule. So f prime of x is equal to, we have 1 times 2 prime plus 2 times 1 prime. All right, so let's look at what that actually looks like. So f prime of x is equal to 1. So 1 is the exact thing that we have for our first function, 3x squared minus 2x plus 5. Okay, and then we're going to multiply that by the derivative of the second. So the derivative of the second is negative 20x to the 3rd plus 6x squared minus 2 times 7 is 14x plus 1. Okay, so that is a lot of stuff in this one as well. Okay, plus now we're going to take the second times the derivative of the first. Okay, so what is the second? Negative 5x to the 4th plus 2x to the 3rd minus 7x squared plus x plus 2. All right, we're going to multiply that by the derivative of the first, which is 6x minus 2. Okay, and guys, that is a whole lot of stuff, whole lot of algebra to do. So what I want you to do there is stop. Okay, I want you to set the problem up. Obviously on the AP test, all right, you would have to finish everything out. But for our purposes, all right, all you need to do is, I want to see that you guys can use this rule. All right, can you use the product rule and can you set these things up? That is all I'm concerned about. Okay? Now that we have an idea of how to use the product rule, all right, what we need to do is we need to go back and look, well, maybe what if I have a quotient? So this is, let me get back on my pen here. This is number 7. We have the quotient rule. Again, this is still on derivatives 21. And we look at, all right, well, what if my functions are divided by each other? So what if f of x is divided by g of x? Okay, we need a rule for that. So what the quotient rule, quotient talking about division, tells us is it's g of x times f prime of x minus f of x times g prime of x, okay, all over g of x squared. Okay, so the simpler version of all that, if we let f of x be 1, g of x be 2. All right, what would that look like? We have 2 times 1 prime minus 1 times 2 prime all over 2 squared. Okay, so that's kind of the easy way to do that, to think about that when you're looking for the derivative of a whole function over another function. Okay, so what would these look like? All right, let's look at part A. So we want to find y prime if y is equal to 5 over 3x minus 2. Okay, so in this case, 5 is my 1, 3x minus 2 is my 2. So we're going to apply the quotient rule, and all I want you to do is I just want you to set this up. All right, I don't really want you to go in and simplify and get too worried about all that. I just want you to know how to set up the quotient rule. Okay, so using our rule. All right, remember our rule is right here. Okay, this is my quotient rule. So quotient rule tells me that y prime is equal to 2, so 3x minus 2, times the derivative of the top. Well, what's the derivative of the top? Derivative of 5 is 0. All right, that helps me out a whole lot. Now we subtract 1, which is 5, times the derivative of 2. Derivative of 2 is just 3. All this is over 2 squared, so 3x minus 2 to the second power. All right, so how does that really simplify? This part goes to 0. We get negative 15 over 3x minus 2 squared. Okay, right now that would be good enough. That's really all I want you to notice and be able to do. Okay, obviously you could do 3x minus 2. All right, and FOIL that out. Okay, if you wanted to, I'm not asking you to do that right now, but you could simplify this further if you wanted to. Okay, let's look at part B. See what part B looks like. So we're trying to find f prime of x if, this should say f of x, that's a typo there on part B, should say that just f of x is equal to 4x minus 3 over 2x plus 1. Okay, so again, here's my 1, here's my 2. All right, we're going to go back to our quotient rule here. 2 times the derivative of 1. So 2 times 1 prime minus 1 times 2 prime all over, all right, 2 squared. Okay, so we're going to use that idea as we go through here and look at f prime of x, or the derivative of f with respect to x. So 2, our function is 2x plus 1. All right, times the derivative of 1. Well, the derivative of 1, the derivative of the top is just 4 minus, all right, all of 1, we have 4x minus 3 times the derivative of 2. So the derivative of 2 is just 2x plus 1. Okay, now this is all over 2 squared. So 2 is 2x plus 1, all right, squared. So this would be something that we could look at. All right, obviously I would probably do a little bit of simplification here. I know that 4 times 2x is 8x plus 4. All right, and then this is minus 8x minus 6. All right, all over 2x plus 1 squared. And I'm just going to simplify because I like to simplify. That's 8x, distribute the negative through, so negative, positive, 8x minus 8x, so that's going to give me 10 over 2x plus 1 squared. And that looks a whole lot nicer than what it did earlier. Okay, so we have some ways that we can do the quotient rule, all right, that kind of help us out dealing with these functions that that would be tough to do otherwise. Okay, let's look at part C together as well and see what these are gonna look like. And then we'll move on and we'll finish up with part 8, 9, and 10. And we'll try to get this video done so that you guys can begin working on some of these problems. Okay, so part C. All right, I want to find dy dx, which just means, all right, that is the same thing as saying y prime. If y is equal to, we have negative x over x squared plus 4x minus 2. Okay, so treating that as my 1, that is my 2. All right, we know that y prime. Okay, again, I'm going to go back to my rule here. 2 times 1 prime. All right. I'm going to write my rule down every time. 2 times 1 prime minus 1 times 2 prime all over 2 squared. Okay, and now all it is just plugging in and applying this rule. Okay, so what is 2? 2 is the whole bottom of that fraction. X squared plus 4x minus 2. Times the derivative of 1. Well, the derivative of negative x is just negative 1. Okay, minus, now we have 1, which is negative x, times the derivative of the bottom. Well, the derivative of x squared is just 2x, plus derivative of 4x is just 4. Okay, and all that is over x squared plus 4x minus 2. All right, and all that is squared. Okay, so now we're going to go through some of our simplification process here. If I simplify the top, negative x squared minus 4x plus 2. All right, and then over here, we have minus, that becomes negative 2x squared minus 4x, okay, all over all that stuff in the bottom. I'm going to keep simplifying this top, so negative x squared minus 4x plus 2, and that becomes plus 2x squared plus 4x over all of that in the bottom again. Okay, so what does that give us? My 4x's cancel. I'm just left with x squared plus 2 all over the stuff that was in the bottom. So x squared plus 4x minus 2 squared. So that is my y prime, or my dy dx. Okay, the last thing that we're going to do is we're going to look at part 8. So this is find the equation of the tangent line. All right, tangent line to the graph at the point. Okay, and we can use our graphing calculator to verify our result, or we can use Desmos to verify our result. So what this is going to go back to is going to go back to point slope. So it's using some point slope form from Algebra 1. And if you remember, that was y minus y1 equals m, and you had x minus x1. Okay, but what we need to figure out is we need to figure out what this m value is. Okay, and this m value for us is actually going to be f prime at whatever x1 is that we're given as our point. Okay, so let's go through and let's look at how we could do this one for 8. So if you look at part A on number 8, we have that f of x is equal to 3x to the third minus 2x squared minus x plus 2 at 1, 2. So what we need to do first, all right, is we need to think about our point slope over here. So I'm gonna use that. This is our equation that we're eventually going to get to. It's y minus 2 equals m. We haven't found that yet. All right, we need the slope of that tangent line. at that point. We have x minus x1 is 1. Okay, so we need to find what this is. We need to find what f prime at x1 is. That's going to actually give us my slope m to plug into this equation. All right, so in order to do that, we need to take the derivative of f of x. Okay, so the derivative of f of x, we have 3 times 3 is 9, so 9x squared, minus 2 times 2 is 4, so 4x, minus 1. All right, and so what we're going to look at is okay, what is f prime at our x1 value? Well, our x1 value happens to be 1. So what happens when I plug 1 into my equation? So I have 9 times 1 squared minus 4 times 1 minus 1. So we get 9 minus 4 minus 1. So that's really 9 minus 5, which is 4. So here at f of 1, we have 4. Okay, so that's what we're going to use as our slope. So we're plugging that 4 in for m. So we have y minus 2 equals 4x minus 1. Okay, and now it's just goes back to algebra 1. All right, go back to 8th, 9th grade. And we're going to figure out how to do this. So that's y minus 2 equals 4x minus 4. Then you add 2 to both sides, obviously. And you get this equation is 4x minus 2. Okay, and that's all that we have to do. We just found the equation of the tangent line. All right, that is the line that's tangent to this function at the point 1, 2. And so what you can do in Desmos is you can plot f of x. Okay, so f of x, you can plot my new equation that I just found, and then you can look at 1, 2, all right, and see that it is tangent, see that it hits.